Well, I should start off by saying that I'm not an economist. In fact, I'm not even taking an undergraduate course in economics. And I was not sure why I was put into this session, but my colleague Dave Gutzler mentioned during the break that some people call economics the science of choice. They probably teach that in the first day of economics 101, but they never took that. And I thought about that during the sessions, and it actually does say that. I am going to be talking about choices people make, and specifically scientific prediction. So one of the things I want to talk about is the avoidance of catastrophe. And this comes from a long history of literature and methodology and probabilistic risk assessment. And this is how engineers deal with this. And I listed 3 bullets, 3 things that you don't want to categorically fail. And I use fail in a very general way. Nuclear weapons failure, well, if one of them went off accidentally, that would be catastrophic. And a lot of people work on that problem and make sure that that can never happen. Asteroid impact is another one. That's how I got into this business. I did my PhD work on impact physics and shockwave physics. And extreme climate change is another. Now, if you define climate failure as an abrupt change that would be catastrophic to society, we know that happens. We don't even have to talk about climate change. We saw yesterday the Younger Dryas, the event 12.9 thousand years ago, that if something like that happened now and there was that abrupt of a change, ecosystems would collapse, agriculture would collapse. So those things do happen, and if you look at the paleoclimate record, they happen more frequently than large asteroid impacts. So personally, I'm more nervous about that than I am about asteroid impacts. This was my introduction to probabilistic risk assessment. Chapman and Morrison did not invent this, and this is actually was originally written as the Morrison report in '91. And what's embedded in this, and you may not be able to read this, is chance of impact per year, and this is asteroid diameter, and this is an estimate of the consequences of an impact. And the consequences, basically, especially when you get into this upper end, this is a logarithmic scale, by the way, when you get up to this upper end, is abrupt catastrophic climate change induced by an asteroid. So people wouldn't be killed by the asteroid itself. They would be killed by the abrupt change in environmental conditions caused by the impact. But we really don't know. There's no way to verify this. This is all based on estimates. It's back in the envelope. And this is a threshold. So this is a threshold for global catastrophe. That's how Chapman and Morrison referred to this. So the probability here is 10, chance per year is 10 to the minus 4. So if you think of this axis, you can project it onto another function, which would be probability density function. So we're worried about things, that have down to 10 to the minus 7th probability of happening next year. But that would be catastrophic, leaving, killing billions of people. So this was the basis for a policy decision. The policy decision was not to worry about the stuff down here. The small stuff, the probability of impact is every decade or so. It has 0 consequences. It doesn't hurt anything. Nobody gets hurt by that. So you worry about the toe of the probability density function, the probability distribution. And so the policy was to build telescopes and to discover these things and to reduce the probability, to reduce the uncertainty in the probability of impact. Because the ones you find, if they're not in collision courses, you take those, and this number goes down, you take those off the list. Something happened in 1994 that convinced people this was important, and I want to digress for a minute and talk about something I wasn't going to bring up, but so I have a poster upstairs where I ask people to make predictions on next year's global mean surface temperature. I think scientific prediction is a very important integral part of science. One individual declined to do it and said prediction is a fool's errand. I don't agree. I don't agree at all. And in fact, in 1994, a group of my collaborators did some simulations, computational simulations, and we published some predictions saying that this would be much, much more, there would be much bigger effect than the consensus view was at that time. So we disagreed strongly with the consensus. But we didn't complain about the consensus. We wrote a paper, we made a prediction, and we were correct for the most part. And that gave us a lot of credibility, and the consensus changed. And that's part of the reason people took this threat a lot more seriously. And Gene Shoemaker, who was the co-discoverer of Shoemaker-Levy 9, said the giggle factor is gone. People used to giggle at this threat. After Shoemaker-Levy 9, they didn't anymore. And getting back to the economic aspect, and what I'm going to talk about, leading into what I'm going to talk about, is when we made that prediction, it was a little bit like buying a contract. We were putting our reputations, that was the cost to us. And if we had lost, our reputations would have gone down, we would have wasted a lot of time. But the fact that the contract paid off improved our reputation. I'd still get to work in this area. I probably wouldn't be if that had failed to come true. So that's like buying a contract. And what I'm going to talk about makes that contract more explicit. So here's, and I'm going to go through this really fast, but this is just an analog for what we mean by probability and consequences and how you do probabilistic risk assessment. So you can think of probability as like how many bullets are in the chamber of a gun, and the consequences are analogous to what direction the gun is pointed. And if you have one bullet that is pointed to your head, you know, that's high consequence. And you know, if you have to fire all the guns, if you have an ensemble of guns and they have this different configuration, and you want to do something to reduce the risk, the first thing I'm going to do is take the bullet out of this gun. Now, I've heard this referred to as a precautionary principle, and you know, and that seems to go with people that are overly cautious. But when I was a Boy Scout up at Camp Tahosa and I was taking gun safety, they told us one of the first rules is you never, ever, ever point a gun at anybody, even if you're absolutely 100% certain it's not loaded. Okay, that's the precautionary principle. That's what the NRA teaches. Because even if you think you're 100% certain, there's a tiny fraction of a chance that there's a gun in the chamber, or a bullet in the chamber, and a small number times a big number is still a measurable number. So, you know, these are the N members. I won't put the names on these, but you know what I'm talking about. And these are people who only deal in certainty. The scientific debate is here. And so I don't think there is a consensus. I know there's not a consensus on what the climate sensitivity is. You know, it could be down here, it could be up here, but this is sort of a consensus PDF. There really isn't a consensus PDF, and that was one of the things that Judith Curry was complaining about on Monday. You know, how did the IPCC claim that there's a consensus PDF? And I tend to agree with her on that. And what I want to present today is a mechanism by which a consensus climate sensitivity can be arrived at. So again, this is just kind of repeating what I'm saying. This is basically the same graph as Morrison and Chapman published in '94. This was 10 years later, and this is very schematic, showing consequence, the threshold, and the estimate of the probability density function. One thing that's still totally unknown is there a threshold, and what is the threshold? Is this some kind of tipping point? Is it a physical tipping point? Is it a tipping point for ecological collapse, agricultural collapse, civilization collapse? And so there's a huge uncertainty on this. Now, in the nuclear weapons complex, there's a methodology called quantifying margins and uncertainty, and part of that is recognizing the uncertainty in any of these thresholds and then defining the margin. We really want to stay away from that margin. That's task one. And you know, one of the things we're told over and over as a motto in the national labs almost is, that applies to engineering facilities and projects and so forth, is whatever you're doing, always think about how this can go horribly wrong. And I think we should apply that to the climate problem as well. So here's why the IPCC PDF is not consensus. So these are a whole bunch of published probability density functions for climate sensitivity they all have tails. Nobody is saying they're certain that the extreme, that the gun is imploded in the extreme case. One of my criticisms of IPCC is, they treat best estimate as what's most important. I disagree with that, because when we do the multiplication integration, this is what's most important. So I started following these prediction markets a number of years ago, and I love, there used to actually be a sports market, and that was always fun to watch. And they're very good at making predictions. I started thinking about ensembles of predictions. This is from a couple years ago during election season. People actually buy and sell these contracts for how many people will get elected to the House in one party or another. And the way it works is if you sell a contract, it's basically a provisional IOU. And you put it on an open market, just like the Chicago Mercantile Exchange. It's a double auction market. And you can make an offer for a given price, and somebody can buy it at that price. And then if what it predicts comes true, they collect. So basically it's betting, but it's betting in a way where it's very consensus because it's a double auction market. And so this is you might think of this as a cumulative density, probability density function. And you might actually use this. You can think of how somebody might use this to hedge. If the party in question is going convincingly to vote against some policy you want, you might buy into this market so you don't lose the money that you invested in the thing that's going to get killed by the new Congress. I'm going to go through very quickly a brief history of global warming predictions. And Arrhenius didn't make a particular prediction, but he did publish the first paper saying that this eventually would happen if we continue to burn fossil fuels and kill them, and it builds up in the atmosphere. Now, he was living at a time where, the light bulb and automobile were just being invented, and he had no clue that, these technologies would take off in the way they had. And he was, this was almost like an intellectual curiosity at the time. He was talking about thousands of years in the future. But what has happened since then? Gilbert Klass made a specific prediction, and he called it climatic change. I think it's interesting that people were using essentially the term climate change in 1955. And at a time when there appeared to be a downward trend, he made a prediction. In fact, in 1956, he was interviewed on a radio program and said 2 degrees Fahrenheit per century. That's a specific prediction. It's his best estimate. He didn't put an uncertainty on it. If I take that out to 2012, next year, this would be what his prediction is. So that seems pretty bold to me when there appears to be a downward trend. Wally Broecker, 10 years later, same thing. He coined the term global warming. He used the old term climatic change, but he coined the term global warming. And again, this apparent downward trend was continuing, but he pointed up here. And in fact, he pointed out, that there was this natural variability, and superposed on that was this exponential increase, and this is what you would get. And so again, bold prediction, almost like Babe Ruth, pointing in the stands. A lot of time for that to come true, potentially. Now this is what now, Richard, you may disagree with this, and you're welcome to, and set me straight. But this is my estimate of what Broecker would have predicted had he used the Linson and Choi sensitivity, and everything else in his methodology was the same. This kind of sensitivity is about 1/5 what this kind of sensitivity is. Let's see, Hansen made some predictions. Now, unfortunately, Hansen's predictions were ambiguous, and it's, if I try to put a point up here, I get a big argument. It might be up here, it might be down here. I simply don't know. Because it was scenario dependent, and it was unclear to me whether he was talking about just land temperature or land ocean temperature. And here's his graph. So you can see he wasn't making a specific prediction. I mean, if you're going to do it right, you put a trend line through here and then, do a probabilistic prediction based on variability. Okay, I'll speed up here. So let's just step through and let's pretend like we don't know what happened. And I think when you look at this one step at a time, and you look at these, I guess I'm changing my metaphor now as goalposts. Is it going to go through the goalposts? It's, to me, a remarkable prediction. I do want to give some counter predictions. This wasn't in the scientific literature, it was in an op-ed that he said it stopped in 1998. I can cast that into a prediction, which would be the same as 98. Of course, this is less like pointing at the stands for a home run, it's more like pointing where your bunt is going to go. We saw this one the other day. I can make I can draw a point there. This is my best estimate of what he's saying. And I can rotate this, and now I can say, let's bet on this. Let's bet on what 2012 is going to be. And there is a series of contracts, just like those congressional contracts now on Intrade. You can get an account, and you can buy and sell these contracts. And here's what the current, or at least when I downloaded the data a couple weeks ago, this is what the cumulative density functions look like. And if I translate these upward, this is the consensus. This is an economic consensus, a consensus by choice. Nobody's forcing anybody to buy and sell these contracts. And this is what it says about these various individuals' predictions. Let's just skip over this. Here's the market. Here's the current bid and ask prices. It's a very thinly traded market. I just want to say a couple words, and in closing the loop with this session, I have to have pictures of dead trees, and also a picture of my daughter with a tree. And she looks like kind of a tree hugger, but this is a family tree farm that's been in her family for a half century. And she has a property right to this tree. So she may be hugging this tree as pride of ownership. It's something she values. It's something she's going to inherit. People are entitled to hug their cars, whatever they want. And it's not for sale. But the problem is her right to radiate photons is being infringed upon by people's right to pollute. So there's a collision of rights here. And I would argue that people do have a right to radiate. I mean, it's almost like an easement, like a prescriptive easement. We've all been radiating all our lives, and now that right is being infringed upon. So how can we generate market liquidity? One way is, and I'm not making a policy recommendation, I'm just making a suggestion for policy framework. You could require greenhouse gas polluters to issue bonds. The bonds could be essentially, you're giving away these contracts. You're not selling them, you're giving away. And if global warming does not increase, they're worthless. Those bonds could be traded on an open market. So now you have a consensus by choice for what the value of those are. And that would be a more effective way to make predictions, collaborative consensus predictions of the future. And I'll close with that, and I guess those quotes speak for themselves.
I should say one thing. I think you have me off with a factor of about 2.5.
Like a factor of 2.5.
Yeah.
You put yourself to a factor of 2.5.
Because essentially the present change is compatible if you exclude the aerosols and so on, with about a sensitivity of 1.8.
Okay. I want to be very precise about how I worded that, and I intended it to be, and the reason I put L, I didn't attribute it to you, but I put L as sort of a mnemonic. But it was if Broecker had used your climate sensitivity instead of his, that's what he would have predicted, because he was not including, as I recall, aerosols.
It does matter. Questions?
This may be a tangent, but I think this has come up in private conversations. So, you know, we're discussing global warming as we should do. Issues like the Sahel, the drought came up. What I'd like to say is, you know, there's even this issue of, as scientists in a modern society, we need to understand natural variability also.
Right.
So it isn't this versus that, it's both.
I agree.
And so even this market, I mean, we do that. In fact, the market does respond to, you know, early frost, early thing. So rather than this being a this versus that, I think we're doing good. We're trying to get at natural variability in the context of secular forcing.
I agree, and I would actually go further and I would say, I mean, if it wasn't for natural variability, it would be very easy to predict next year's global surface temperature, and it's, you know, it's the spread in that probability density function that is the measure of natural, or best estimate of natural variability.
Here. It seems to me with all the kind of data you're looking at,
I'm sorry, I can't.
Could Anthony Davis, IGU.
Unless there's an acoustic issue, like
Okay.
where you're
Can you
sitting.
hear me now?
No.
Is
it on?
Like this.
Oh yeah. Okay, now.
Okay.
Good. Okay, maybe I just would like to talk a little bit, if you know anything, about the idea of climate derivatives, because it seems to me it's kind of in the same arena.
There are weather futures that are traded on the Chicago Mercantile Exchange. They're for specific cities, and they're like month-to-month things that go, or at least last time I checked, they're month-to-month contracts that go about a year in the future. And utility companies and others use them to hedge, so to smooth their profits, to avoid big losses when there's an unusual cool summer and they don't sell as much electricity, that sort of thing. And they're actually, at least when I checked, they were quite liquid because they were actually being used for purposes other than prediction.
Fred, did you have a question?
Well, just a historical point. Gil Plass was a colleague of mine at the Johns Hopkins University.
Right.
And as I recollect, and I may be mistaken on this, his contribution was to examine the spectral lines of water vapor and CO2 in some detail and come up with the conclusion that there was not enough of an overlap so that CO2 would become an effective greenhouse gas. I believe, and I'm trying to recollect this now, which is many years ago, that there was an opinion at the time, a prevalent opinion, that water vapor would swamp CO2. So that increases in CO2 would swamp.
What would swamp? Water vapor, okay.
Water vapor would swamp CO2. So the CO2 would not be an effective addition to the greenhouse effect. This is something that can be checked, of course.
Sure.
We're out of time. I have to defer to Peter. Should we take one more question?
Let us have discussion with
Yeah, let's start the group discussion.